All right, so we're going to go ahead and look at this guy here. So we're trying to find an error. So when I look at this first one, I see this bottom one here and this bottom one here, and I say, all right, check, check, nothing seems to be weird. I see that this guy here is factored as x plus 5 and x minus 5, and it's on the top, which is good because division is multiplying by the reciprocal. So that seemed to be just fine. This one here multiplies to get negative 15 and adds to get a positive 2, so that one seems to be just fine, and that one moved to the bottom. This one here doesn't look so good. This one here, if I pull out an x as a common factor, I would be left with x minus 3. And that's not what I have here. So that is what we should have. So now when I reduce, I end up actually just getting plain old x as my answer. So let's go ahead and look at 15. So 15 says choose a value for x and then plug it into x to show that this is equivalent to this. Now when I factored this, I would get 2, pull out a 2, I would have x squared minus 25, which would be 2x plus 5, x minus 5. This one here is actually, if I pull out a negative, I'm left with a positive x and a negative 5. Did you catch that? So then those cancel, and I'm left with a negative times a 2 times an x plus 5, which is what we have here. So what we're doing is we're plugging in a number. So you don't want to pick 0. You don't want to pick 1 because sometimes those things don't quite work. So pick like a 2 or a 3 or a 4 to plug in here. So I'm going to go ahead and plug in a 2. So I'm going to, actually, I don't even want to do a 2 because sometimes 2 times 2 squared and 2 times 2 is different. So I'm going to plug in a 3. So we'll do 3 squared minus 50 on the top, and then 3 or 5 minus 3 on the bottom. So the bottom becomes a 2, and the top becomes 9 times 2, and then minus 50. So I get negative 32 on the top. And negative 32 divided by 2 is negative 16. Now, when I plug in a 3 here, I get negative 2 times 3 plus 5 is 8 times a negative 2 is also negative 16. And here's the deal. Your original and your new have to be equal to each other if all you've done is reduce. Because when we're reducing, we're saying 4 over 8 is really equal to 1 over 2. They have to be equal to each other. So my original and my new have to be equal to each other. So if you plug a number into the original and plug a number into the new, they need to be equal to each other. So how do we use that? We can go back up here and say, I want to know if this is correct. So I'm going to plug in a 3 into my x's. So I'm going to do 15 over 3 plus 5 times 3 over 3 squared. So this is 5. This is 15 over 9. And then this is 20 over 3. So 20 divided by 3 is 6.67. And 5 plus 15 divided by 9, just kidding, is equal to also 6.67. So if what you plug into the original and you plug into the new are equivalent, that at least gives you a pretty good idea that you are correct. So great tool to use.